Hey everybody, Dr. Gilchrist here, and as promised, I'm going to spend maybe about 20 minutes, give or take, just going through a little bit more about classical conditioning and starting to move into operant conditioning. So my game plan is for this to take no more than 20 minutes. I'm going to go ahead and put on a timer just to make sure that I get pretty close to that time period. And because it's kind of hard to watch this when I'm on Zoom. So I'm going to go ahead and zoom in and we're going to pick up where we left off last time. So the last time that we were here, we were talking about classical conditioning and the different phenomena associated with classical conditioning. So this includes things like extinction, spontaneous recovery, generalization, and discrimination. So one of the things that I kind of brought up at the end of class that I think is really important to know is that so far, I've been talking about classical conditioning in a very laboratory-driven way. We pair a tone with an air puff. We pair a bell or a tone with some meat to get a dog to salivate. And as you can kind of see, these are examples that don't really seem to have too much application for our everyday life. And so one of the things that I think is really useful is that a lot of the fears that we actually have are actually acquired occasionally through classical conditioning purposes. So phobia, which we will talk about closer to the end of the semester, which is technically treated as a psychological disorder, is an acquired fear of an object or a situation. Now, compared to something like a simple fear, a phobia typically will have a greater extent of avoidance and greater use of behaviors to potentially avoid that situation. So for example, I don't really like thunderstorms. And so sometimes, especially if the thunderstorms are really bad and there's a lot of wind, I might go and hide out in my house's basement where I tend to feel a little bit safer. That's probably a simple fear. A phobia, on the other hand, would be if I knew that a series of storms was coming through the area, I might try to get in my car and drive to anywhere that I possibly could that would give me an opportunity to kind of miss those storms. That's a greater extent of avoidance, and it's much more disruptive to my everyday life than me going and hiding in the basement. Now, one of the things that we find is that certainly not for every fear or phobia that we have, but some fears and phobias are actually acquired through classical conditioning. So if a dog bites us, it's not necessarily this fear may transfer to other dogs because of that negative bite experience. But one of the things that we know about how classical conditioning can lead to the development of fear comes through the very famous Little Albert study. And so what you're looking at here is a very well-known study from the early 20th century, where John Watson and his graduate student, Rosalie Rayner, basically tried to use the principles of classical conditioning to create a fear of a white rat in a 9-month-old infant. Now, at the time, this 9-month-old infant, we didn't really know that much about the infant. We later found out that he was the son of a wet nurse at a hospital, but he was kept anonymous and was identified through the name Little Albert. And so originally, this 9-month-old infant was presented with neutral objects. So looking at different types of animals. So they presented the infant with things like rabbits, with monkeys, with a white rat. And at least at 9 months of age, the infant is not really had enough life experience or enough exposure to know to be afraid of these things. Oftentimes our fears are learned either through our experiences or by watching other people. And so about 2 months later, Watson did this. And this is what is particularly, this is part of the reason why you can't really do this anymore. So what they would do is they took the 9-month-old infant and they took the infant and they put him in the room with the rat. And then as soon as the infant would start to kind of move toward the rat, Watson was basically right behind the infant and he would hit a metal bar with a hammer. I should note that this is behind the infant's head, which is probably not the safest way to do things, but hitting the bar with the hammer creates a loud noise. Now, instinctually, loud noises for anybody are going to create a startle response. And in the case of a young infant, this is going to create fear. So every time that the infant would try to reach toward the rat, Watson would basically produce that loud sound to the point where just the presence of the rat in the room would terrify the child. And the child would start to crawl away from the rat. The rat was no longer this neutral object of curiosity. By repeatedly pairing a loud noise with the rat to produce fear, that fear then transferred over to the rat. And what was especially remarkable is how well little Albert's fear generalized to other types of objects. So they later presented little Albert with things like a rabbit, a researcher's fur coat, and even this creepy Santa Claus mask. And as you can see, now he fears even Santa Claus. And this is an image from the actual study itself. So let's go ahead and break this down into classical conditioning terminology. So prior to our conditioning, we have our rat, which is basically functioning as our neutral stimulus. And eventually, we're going to want it to be our conditioned stimulus. So we have our unconditioned stimulus, which is a loud noise. This produces fear. So when we repeatedly pair a rat with that loud noise, we are going to get fear. So the rat will always be an indicator that a loud noise is about to happen, that something scary is about to happen. And so what ends up happening when we repeatedly pair this neutral stimulus, this rat, with the loud noise is that the rat itself will eventually become a conditioned stimulus and will thus produce a conditioned response of fear to a rat. If we present little Albert with stimuli that are similar to the rat, such as a furry, fluffy rabbit, we are going to get generalization. And again, little Albert will not only be scared of the rat, he will also be scared of the rabbit. So one of the other things that people kind of criticized the little Albert study for was that they never actually tried to reverse the conditioning. And so one of the things that we know from an ethical standpoint is that you always remember to leave your participants like a campsite, leave them the way you found them. If you have conditioned fear into an infant, you need to try to undo that. And so in 1924, this was actually the work that Mary Cover Jones did, something that we refer to as counter conditioning. So if we want to undo a fear of something, whether it was conditioned or not, we can pair a feared object with something pleasant. So maybe we pair the rat with something sweet like candy. We pair the feared object with something pleasant. So now the association is not being made between the rat and a fearful object, but a rat and a pleasant object. And thus we can create pleasant feelings that transfer over to the rat. Now, one of the other big things that we can do if we want to reverse the fear that we have of an object is we can do something referred to as systematic desensitization. So what we do in this instance is we pair relaxation techniques to help get us in a calmer state of mind, almost as an unconditioned stimulus. And we also engage in repeated exposure to an object. And by combining these, we can begin to associate the object that we fear with a calm, relaxed feeling. And we do so in a very systematic, hierarchical way. We don't start with the scariest thing that somebody can imagine. We start with something doable, and then we increase the level of difficulty and the amount of fear to help undo that phobia. So now we are going to move on to talking about operant conditioning with the 10 minutes we have left. And then I will talk some more about observational learning in class with you. So now we're going to talk about the ways that we learn from operant conditioning. So before we move any further, we do need to, once again, explain the difference between classical conditioning and operant conditioning. So just as a review, classical conditioning is when we make an association between two uncontrollable events. You cannot control the presence of lightning or thunder, but you are going to begin to develop the association that the presence of lightning will predict that thunder will soon arrive, and you at that point will begin to engage in behaviors that anticipate that loud burst of thunder, such as bracing yourself. Your behavior is largely going to be a passive response. The learning is very passive. You do not control either of these events. But what's really critical here is that you are making an association even though you don't control them. On the other hand, with operant conditioning, you make an association between an action that you engage in or a behavior that you engage in and the consequences of that behavior. So the only way that you are actually going to learn about this is by engaging in the behavior. So whereas classical conditioning is associated with a very passive response, the behavior that is required and necessary for operant conditioning to occur is an active response. Part of the reason that we call it operant conditioning is that for this type of conditioning to occur, somebody actually has to operate on the environment. You are not going to learn if you do not act. So one of the first people to actually look at operant conditioning was Edward Thorndike. And what he ended up finding was that behavior will often either be strengthened by reward and it is reduced by punishment. So in general, he calls this his law of effect. Outcomes that so behaviors that lead to favorable outcomes are likely to be repeated. Behaviors that lead to unfavorable outcomes will not. And a lot of what we know about the law of effect came from the work that Thorndike did by putting cats in these wooden puzzle boxes. And so he would take a cat, and within this puzzle box are a series of pulleys and levers that a cat will have to push against or bat at to be able to escape from the puzzle box. And once the cat actually escapes from the puzzle box, it receives a plate of fish as a reward. That's a pretty good reward for a cat. Now, what's interesting is that Thorndike would put these cats repeatedly in the puzzle box. And as he did so, he discovered something really interesting. So if you look over to the left, I actually have a graph that kind of looks like some of the data that Thorndike obtained from a cat in a puzzle box. And what you can kind of see is on our y-axis, we have the time that it took to escape the box. And then on our x-axis, we have how many trials each cat was in the puzzle box. So here is data for a single cat. And so what you can see is that initially on the very first few trials, it takes a while for the cat to escape the box. It's very much happening by accident. So a cat initially, when it escapes the box, it doesn't exactly know what it did. By and large, for the most part, a cat's first escape from the box will be accidental, but there's still learning going on. We find that with successive trials, the cat gets better and better and better at escaping from the box very quickly, indicating that it is learning from what is happening to it. And it's learning that the quicker it gets out of the box, the more quickly it gets that plate of fish. So a lot of the work on operant conditioning that was initially done by Thorndike was then advanced by the work of B.F. Skinner. And one of the ways that B.F. Skinner did a lot of his research on operant conditioning was by working with rats. And so this is what is referred to as an operant chamber. We also call it a Skinner box. But the basic idea is that we put a rat in this box that is equipped with a variety of different things. So there is water. There's a dispenser for food to come out. This is sometimes also called a magazine. We have a lever so that the rat can learn to press a bar. We have a light. So under certain circumstances, a rat can learn that it only gets rewarded if it presses the bar while a light is on. We have a speaker that can play different tones. So again, a rat can make the association that it only gets rewarded when the tone is playing. And it's kind of hard to see and appreciate in this figure. It's a little easier to see here, but the floor of this operant chamber is actually wired with electricity. So if you would prefer to punish your rat with a little bit of a foot shock, the floor does contain a little bit of electrical wiring so that you can deliver a tiny little unpleasant foot shock to punish the rat. So when we want to train a behavior, one of the things that we are going to find is that reinforcement tends to work very well. In general, reinforcement is anything that increases a behavior. So for example, an example of reinforcement might be for every time that you answer a question correctly in class, I give you a piece of candy. Now, odds are pretty good after a while, you are going to become more likely to answer questions in class and raise your hand in class to get those reinforcers. So if you want to figure out if something is reinforcing a behavior, look at the behavior itself. Is it increasing? Is it more common than it used to be? If so, something is probably reinforcing it. So if we want to train a new behavior, and oftentimes we will see this with pets, but this is something we can also do with people, we can guide somebody toward a target behavior through successive approximations of that target behavior. And this is what is known as shaping. So if you want to shape your dog to behave with clicker training, train your cat to use the toilet, or if you are in a learning and conditioning class, your rat is not going to be able to press this bar right away. Your rat does not come with the ability to press a bar. You actually have to shape it to press the bar. So how would this work? So what we do is we think about what are some approximations to the target behavior. So maybe initially we only reward the rat when it goes toward the back of the cage where the lever is. So every time it's at the back of the cage where the lever is, we give it food. So eventually the rat is going to realize that the back of the cage is where it needs to be. At that point, when it's consistently going to the back of the cage, we will only reward it if it rears up on its hind legs, because that's going to be a behavior that's necessary for pressing the bar. So eventually the rat's going to be really good at rearing up on its hind legs. And once it's able to do that, at that point, we can make sure that it gets closer to the lever. So maybe we only reward it if it gets really close to the lever. And once the rat's really close to the lever, what we'll often tend to find is that at that point, because we've rewarded those successive approximations to a lever press, at that point, the rat is probably going to press the bar by accident and get reinforcement on its own. And it might take a few more tries for the rat to understand that pressing the bar is the behavior that we want at this point. But if you have shaped those successive approximations to a bar press, eventually the rat will start to press the bar on its own. And so shaping can actually be a really powerful way to create new behaviors and new habits. And so at least at the beginning of class on Wednesday, I'm actually going to show you rat basketball. So I'm going to stop with this slide. So let me go through this and then I'll go ahead and quit. So we have to start by talking about reinforcement. And when we talk about operant conditioning, reinforcement is any event that increases the behavior that it follows. So positive reinforcement is pretty straightforward. Positive reinforcement is basically when you add something that is desirable. So for example, you get a paycheck, or you get a hug, or you get a piece of food every time you press the bar. So we're going to add a desirable stimulus, and as a result, it's going to increase the likelihood of that behavior occurring in the future. Now, here's where people tend to get a little bit mixed up. Negative reinforcement is not punishment. Punishment will always decrease a behavior. Reinforcement, by its very nature, is going to increase a behavior. So negative reinforcement, at least in pop culture, is treated the same as punishment, and that is not the case. So negative reinforcement is basically the idea that I increase the likelihood of a behavior by removing a negative stimulus of some kind. So if I have a headache, I can take some Advil. My Advil gets rid of the headache. So this behavior, the next time I have a headache, I'm going to be more likely to reach for the Advil in the future. That is negative reinforcement. I've increased the likelihood of a behavior by taking away something that is painful or aversive. Likewise, negative reinforcement, for example, might be if you go in your car and you start driving and you don't buckle your seatbelt, at some point your car is going to repeatedly beep at you because you don't have your seatbelt in. So what you're going to do to basically make that noise stop is buckle your seatbelt. That ends the aversive stimulus. And in the future, you're probably going to be more likely to buckle your seatbelt quickly so as not to have to deal with the beeping sound. So negative reinforcement also increases behavior, but it does so by taking something bad away. So positive reinforcement adds something good, negative reinforcement takes something bad away. And we'll talk about punishment and the differences between reinforcement and punishment next time. Bye. And end.